Hello everyone, and I'm introducing you to my very first data science video. In this video, I'm showing you how to make your very first machine learning model. So let's define machine learning. So machine learning is a algorithmic process that uses various types of algorithms like k-means, linear regression, ordinary least squares, image classification, etc. to analyze and draw inferences from patterns in data. So some examples are going to be regression, clustering, classification, and dimensionality reduction. Particularly the model that we're making today is going to involve linear regression. So yeah, that's going to be it. Now also it's very useful for understanding the difference between artificial intelligence and machine learning. So artificial intelligence are basically virtual or physical objects. Now, yes, that allow you to add like whatever you have machine learning or deep learning models in order to make them function. So for example, you can have a robot. Robot can be considered AI because it can add some sort of machine learning functionality or some classification to know whether it hit some walls or not. Chatbot is good in natural language processing and especially generative AI as well because utilize deep learning. So some examples of generative AI models are GPT, Claude, Gemini, Meta, Copilot, and etc. And then of course you have the big daddy of the fields, data science. Now, machine learning actually falls between math and statistics and computer science. But yeah, there is also, for the math, it is kind of useful that you learn basic statistics, probability, calculus, and linear algebra. And then for some business knowledge, you can obtain it by applying to some internships, and that's going to be better. And computer science is basically what you can do basically on your side projects. From the bridge between computer science and business knowledge, you'll have software development, and I'll also consider software engineering here as well. For business knowledge and math and statistics, there's traditional research, which obviously doesn't. And then you have data science, which combines all three, computer science, math and statistics, and business knowledge all in one. Which is why you see data science a lot in the industry, research, and in software development. Okay, so there are various types of machine learning algorithms, but there are three fundamental ones. So first of all, there is supervised learning. So supervised learning, it allows models to analyze and make decisions based on labeled data. Like for example, you have the ordinary least squares, which is an example of a supervised learning algorithm, which by the way works with some labeled data. There is also some more, like there's a linear regression, logistic regression, then there's a image classification, and then there's also unsupervised learning, which basically analyzes and makes decisions based on unlabeled data, which primarily if there isn't any obvious cue in the data, something like unsupervised learning would have to be done. So such example would be categorizing or clusterizing. So for example, you have k-means clustering. And then you have reinforcement learning. Now this is very advanced, or it allows the model to make decisions and receive feedback through interacting with some sort of environment. Some example is like active learning, and I'm actually doing research on active learning right now. Though it is cool to understand, there are some formal prerequisites to understanding this. First of all, you will need to understand some Python and data analytics. Since we are working with Python, you want to understand the basics in depth. Like you have variables and data types, lists, tuples, sets, and dictionaries, conditional statements and loops. You need to know about functions and especially parameters because you'll be using them in the next thing, classes and objects, and we'll be using classes and objects, and exception handling is also good to know as well. And then also the data analytics is going to be very useful. I am going to guide you through how exactly to use those libraries to analyze data, but it's good to know NumPy, Pandas, Matplotlib, and Seaborn. Now, NumPy is good for particularly scientific and mathematical calculations, and it also allows us to work with arrays in Python. So Pandas is typically a library that allows you to perform CRUD-like operations, which is exactly as it is in like a database. So essentially, it is like the database for data analytics. You can have you can store like let's say some data into like a data frame which is equivalent to a table, and then you can have methods to select rows or do SQL-like operations like And then Matplotlib and Seaborn are both libraries for plotting. Matplotlib is just a basic library that offers like, basic plots like there is a bar graph, line graph, scatter plots, box plots, etc. But then Seaborn has a lot more, such as like pair plots, and we will be utilizing a pair plot for the data analysis part. Seaborn is also primarily used for styling. It allows you to add more advanced colors, so that's going to be very good for like analyzing the diagrams, but we are not going to be using Seaborn a whole ton. We're just going to use it for plotting the pair plot, and that's pretty much it. And now we're going into scikit-learn. Now scikit-learn is the primary library that we're going to be using for training this model. Now this is a machine learning model that is compatible with Python, and it supports various machine learning algorithm types. And I discussed the supervised learning, unsupervised learning, and reinforcement learning. And yeah, it supports all different ML algorithms type, like image classification, linear regression, the naive one, and then there's also rich regression, which is more of a variation of linear regression, and pretty much more. It also allows you to train the model easier, and we're going to talk about the train test split later on. It is open source and is commercially available, meaning that you can contribute to the repository that it's hosted on. It's a GitHub repository, but I'm going to link the GitHub repo so that you can try contributing to it if you're looking for something open source. And then this library is also built on NumPy, SciPy, and Matplotlib. The machine learning algorithm that we are actually going to be using is called ordinary least squares, which is a linear regression model. This is basically the standard naive linear regression algorithm, which obviously doesn't rely on the use of hyperparameters. And then it is suitable for data that if data is increasing at a polynomial rate, then ordinary least squares is not ideal. This is also not ideal for outliers. Like for example, there could be a point, like let's say right here. This could be a potential outlier instead of here. Then the linear regression model will end up changing the line and will end up missing all of these points. Now let's actually understand the steps to actually making the model. So the first thing to do is obviously find a dataset, or you can make your own dataset by means of web scraping. You can use either Selenium or Beautiful Soup to complete the process. But either way, you will want to store all this data somewhere, preferably CSV or Excel. And then what you want to do is store the contents inside of a data frame. And then what you want to do is essentially prepare for machine learning. So what this means is that you want to go ahead and clear up any discrepancies, like for example, duplicate columns and empty values. You will then want to analyze the data to check for any patterns. So this is basically going to be where Matplotlib and Seaborn are going to be used. And then for the fourth one, you want to choose the columns that you want to be involved in your training. So whether you have your columns, you will want to store them in your X data and Y data. And then what you want to do is reshape both arrays to make sure they're compatible with the train test split. So that is useful as well. And then the sixth one is actually where we do the machine learning. We're going to split our data into training and testing sets. And we will see why they are important later down the line. And then what you want to do is add your training data to the model. We'll basically do this with a standard fit model. So I forgot to say implement your model, whether it be a linear regression, k-means, and then maybe you want to optimize your model. In this video, we won't actually be optimizing our model, but we're just going to, well, this just focuses on actually making the model. So that's going to be it for this thing here. Now, why do we need the train test split? Now, the model should be familiar with all different types of data, and it should be working with like all types of purposes, whether that be active learning, which is what I'm doing research on right now, or classification, or even regression. All types of data should be considered. So then it also allows us to check to see if we overfit or underfit data. Now, overfitting and underfitting, what is the difference? Now, overfitting occurs when the model is either too complex and contains such irrelevant information, if you forgot to like clean up the data set, and also if your training data is more accurate than the testing data. You will see that later when we do our hands-on demonstration. And then underfitting is basically if the model is a simpler one, but it fails to make accurate predictions based on the training data, and there isn't too much of a spread between numbers. and the predictions are off for essentially most of the data points in your training set. So yeah, that's the primary difference between overfitting and underfitting. You want to make sure you reduce both as much as you can.